All right, guys, your attention, please. Let's begin. So we're doing, of course, mean, median, and mode. And we're going to extend the lesson further. Let me go ahead and drag that upward. So we're going to extend this lesson further. And just to start with something that we haven't probably gone over, there's a good question here that talks about air quality is a survey that they have done. And it says that 1,040 people responded to the survey. And people said the air quality was better. 346 responded to that. Worse, 450. And the same, 244. So could you find a mean and the median and the mode for this data? How would you find the mean? How would you find the mean? Add them all up and divide by how much? By 3. Okay, so I want to make sure that we understand. And give me a second because I got to share the screen. So here's the screen. Let me make sure we're recording it. So here's the problem with that. Let me show you what this means. This data means this. It means B, 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 346 times. It means worse, 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 450 times. And then same, 244 times. You cannot do the mean or the median for this type of data. This is qualitative, categorical data. It's not numbers. You cannot do the mean or the median for it. The mean and the median are reserved for quantities. Okay, so it's a trick question. So if I were to ask you on a test or a quiz, hey, do the mean, and you see they have categories, you can no longer do it. Does this make sense? This 346 means the frequency of something. Does that make sense? Any questions? That's important. But what's the mode here? Can you do the mode? Which one occurs the most? Worse. So you can actually say, yeah, the mode is worse. You can actually do that. I want to be, bless you. I want to be super clear with that because sometimes we get caught up on just doing the math without thinking that the math has to be related to some sort of data. Okay. So I'm going to go ahead and talk about not a new, I guess you could say it's a new type of mean, but in reality, it's not really new. Okay. And let me drag up the page. It's not really new. It's called weighted mean. Weighted mean. So let me go ahead and use this ruler here. And let's go ahead and talk about weighted mean. So the weighted mean is defined as X bar equals the sum of X times the weight divided by the sum of the weights. That's how it's defined. Okay, I guess you could switch that to mu if you were talking about a population. Don't overthink these things. Okay. But that's how it's defined. Okay. So I want to go ahead and do an example from the book. This is question number 41. And question number 41 is page 77. So I'll go ahead and write here, page 77, number 41. Homework. And then we have a score here. And we have the weight here. As you know, not all grades in school count for the same amount of grades. So for homework here, the person got an 85. It could be combined score or whatever, it doesn't matter. And it only contributes 5% of your grade. The quiz, they got 80. In quizzes, I get combined score. And it's 35% of their grade. There was a project. This person got 100% of the project, but it only contributes 20% of the grade, which is quite a bit. Speech was 90%. 90, I guess it scored 90 with 15% contribution. And the final exam, I'll write FE, you got a 93 with a 25% contribution to the grade. So what I want you to realize here is that you can't just, if you just went 85 plus 80 plus 100 plus 90 plus 93 and divided by 5, you would be incorrect. Because that means each of the assignments or categories there would be the same weight. And that's not what we want. What we want to do is to make it an allotment for how much weight each of these scores contribute. So the way this is going to be done is you will go ahead and go, okay, the first score is 85, and it will only contribute, I guess you could look at it as points, 5% in total. So you go ahead and multiply it by 0.05, which is a decimal representation of that percent. That's the first thing you do. Then you continue, say the next one is quizzes. Well, that they got an 80 on that, and it contributes out of the 80, what we're going to contribute to it is 0.35. Right? And the next one will be 100, but of those 100 points, I guess you can look at it as that way, only 20% of those contribute to the total score. You multiply by 0.20. And then the next one will be a 90, but only 15% of this. And again, we write the decimal representation of 15%. And then 93 points, I guess you could say, only 25% will be weighed in. Let me get out my ruler. Make a nice little division there. So let's talk about the bottom, which is the weights. Well, all you do is you just add your weights. 0.05 plus 0.35 plus 0.20 plus 0.15 plus 0.25. So this is a much more different calculation. It's very different than the previous one you would have done. So if you take 85 and multiply by 0.05, you get 4.25. If you take 80 and multiply by 0.35, you get 28. If you take 100 and multiply by 0.20, you get 20. You take 90 and multiply by 0.15, you get 13.5. You take 93 times 0.25, you get 23.25. If you add up 0.05 plus 0.35 plus 0.20 plus 0.15 plus 0.25, you get 1.0 for the sum of the weights in the denominator. I'm going to add the numerator. And we get 89 divided by, I'll just make it consistent, divided by 1.0. So your X bar here is just 89. This person got a very high B, depending on the scale, obviously. So that is more involved than just, if you did it wrong, you would have gotten 85 plus 80 plus 100 plus 90 plus 93 and divided by 5. If you would have done that, you would have gotten 89.6. And some of you might complain and say, well, that's close enough. I'm like, yeah, maybe in this example would have made a difference. But there's various times where you do this where you're completely off because it's, just depends on the numbers themselves. Depends how the weight's weighed. So it's not a big deal, but this is incorrect. You would have done it that way, I would have marked it wrong. When you try to figure out how you're doing in this class, for example, you gotta take weight into consideration. Without taking weight into consideration, you cannot figure out the appropriate letter grade you should get or the GPA. All right, so let's go ahead and take a look at that for a second. So I'm gonna use actual grades from this class, from a particular student. But of course they won't be identified because why would we identify them? Okay, let me go ahead and change the board up there. So let's say, in my class, I gave you a 0.25 for classroom procedures. So one of the categories is classroom procedures. You know that the weight for that was, and I'll go ahead and put score, I guess, and then weight here. You know that the weight for that is 0.25. And then the next thing was a quiz on the frequency. So I'll call it quiz F. Freak. That one was worth 1. Then we took it again, right? And then I doubled the grade, right? Remember, I kind of like said, I'll replace the grade and I'll make another category. So we'll call this quiz. And I'll just put a second here. And this was also worth 1.0. But then I'm like, hey, I'm angry at you guys. We'll take it again. Can't believe that you guys can't get this. And 1.0 here. And then we took the tests, the big test, and that was worth 2 grades. And then we did dot plot, and that was worth 1 grade. And then we did stem and leaf, and that was worth 1 grade. And then we did pie chart, and that was worth 1 grade. And then we did a calculator check. My gosh, we got so many grades. And that was worth 1 grade. And then we did mean, median, mode test. A simple one, mean, median, mode. And that was another grade. So it's not a big deal, but there is some changes in weights here. By the way, calculator check. No, you got your calculator? All right, so you know what happens. The X becomes bad grade. Is Alex here today? You got it? Good. And Christian, is Christian here? All right, good. Huh? Where's Christian? He's not here? Okay. That was just for the people who didn't have the calculators last class. Yeah. Do you have yours today? Caitlin, Ray. There we go. All right, so let's put some scores here. Let me pick a person with an interesting set of grades at least. Okay, there, I picked this person. So this person got an A for the classroom procedures. Got an A on the first frequency test, another A, but then they took a D for the tests, right? And then got an A for the dot plot, an F for the stem and leaf, a 0 for the pie chart, an A for the calculator check, and an F for the mean, median, mode. Okay. So how would we figure out what grade this person should have? So what is an A worth in our grading scale? 4. What about a B? 3. C? 2. A D? And an F? Okay, so I'll write those down. A is equal to 4. B is equal to 3. C is equal to 2. D is equal to 1. And F is equal to 0. So now we need to carry out, yes. Say that again. Last name. Oh, that's why you were telling me Kevin, right? All right, so let's fix it. All right, so let's begin. We have X bar equals the sum of X times W divided by the sum of W. So that's going to be 4 times 0.25, right? Plus 4 times 1 plus 4 times 1 plus, again, 4 times 1 plus 1 times 2, right? Let me make sure. 1, 2, 3, 4. Okay. Plus 4 times 1 plus 0 times 1. That one hurts. Plus 0 times 1 again. Plus 4 times 1. plus 0 times 1. Okay, so we're good there. And now we add the weights at the bottom. The bottom will be the bottom, the denominator. Plus 1, plus 1, plus 1, plus 2, plus 1, plus 1, plus 1, plus 1, plus 1. So we have 1, 2, 3, 4, 5, a 2, a 1, a 1, a 1, and a 0.25. All right, so we begin carrying out this math. 4 times 0.25 is 1. 1 plus 4 plus 4 plus 4 plus 2 plus 4 plus 0 plus 0 plus 4 plus 0. 0.25 plus 1 plus 1 plus 1 plus 2 plus 1 plus 1 plus 1 plus 1 plus 1. The sum of the weights is 10.25. So now we take 1 plus 4 plus 4 plus 4 plus 2 plus 4 plus 0 plus 0 plus 4 plus 0. I get, 1 second, because I pressed the wrong button now. I get 23. And now I take 23 and I divide it by 10.25. And I get, and let me go ahead and highlight that number. I get equals to 2.2439. Da, 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 da. So this person has a 2.24, which is a C. Now, again, this takes into account the weights of the grades. If I would have done this incorrectly, like some of you want to do it, you would have done 4 plus 4 plus 4 plus 4 plus 1 plus 4 plus 0 plus 0 plus 4 plus 0, all divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you would have added all these grades up. 4 plus 4 plus 4 plus 4 plus 1 plus 4 plus 0 plus 0 plus 4 plus 0. You would have gotten 25 divided by 10, which gives you a 2.5. This would have been incorrect. When things have different weights, when grades have different weights, or certain items have different weights, you have to allot for them. If not, you get it wrong, and you won't know how to calculate. In this example, you saw, compared to the first example, you saw how it made a big difference in terms of the numbers. You might say, oh, well, that's a B, or 2.5 is a B. You say, oh, it's just 0.26 points away. That's a lot. That's a lot. So it makes a difference. It makes a difference. Okay. So now here's one I want you to do. Oh man. Give me a second. I gotta close Adobe. Let me close Adobe by mistake. I opened up Adobe. I want you to try this one on your own. This is weighted and mean. Give you a few minutes to work on it. But I think it's an interesting question. So it's in regards, this is number 46. on that same, on page, actually on page 78. Oh, I'll scroll up. Hello, cowgirl.
I was gonna ask you because last class I left early for bowling because I missed
Yeah, you need to
the
make up the food.
yeah, and then this class I
When you
made
wanna
early
go?
again. So I was gonna see if I can make up the burrito
When?
today, like right now. Because I don't want it to
Okay.
like pile up, because I'm missing today this class again. So I don't want it
Okay.
to like start piling up.
All right, give me a second. I'm in the middle of that. All right, how long will it stay here?
Like I mean, I just need to watch the stuff that I don't do.
Okay. Okay. So I want you guys to try this. It's called, this question is for number 46, it's called scores. It says the mean scores for statistics course by major are given. What is the mean score for the class? So in this class, you have 9 engineering majors. So we'll just, and they scored an average of 85. The 5 math majors, they scored an average of 90. And the 13 business majors, obviously they scored the lowest ones, 81. So now, could you please do the mean for that? Could you please do the mean for that? Let me see if I can be sophisticated here and just pause this. Let me get my mouse. So I'm gonna go ahead and just from here. I don't know how to pause it. Oh, there. Not pause share. I want to pause the video. Pause. Okay, so all right. So let's talk about. Okay, so you said 9 times at 0.85. What if so I should have been clear. So this was a score, right? Was this the grade? Maybe I should have been clear about that. So that's the grade. So what do you think the weight would have been? Yeah, so it would have been 85 times 9. See, you don't have to have the weights as percentages. You see, you have 985s, right? And then you would add to that 5 90s. And you would add to that 13 81s. You see? All divided by 9 plus 5 plus 13. So this would have been your X bar. And again, we're following the formula here. The formula is X bar equals the sum of X times W divided by the sum of W. So realizing that this was the weight, and of course I could have been more precise about it, is what's more important here than anything else, because now you have the number set wrong. Although you would have gotten an answer that's proportionally the same, but you would have been off by 2 decimal places. That's all. So we have 85 times 9. That's 765. You got 90 times 5, which is 450. And we got 81 times 13, 1,053. 9 plus 5 plus 13, that's a 27. That's a 27. 765 plus 450 plus 1,053. That's 345,303 divided by 27. And so we have something really wrong here. I must have messed up adding, guys. 2,000. I must have multiplied somewhere. There, I see it. I multiplied by mistake. I multiplied 765 multiplied by 450. Sorry about that. You know what I'm gonna do? I'm gonna buy my trusty 68, right? My trusty TI-84, because the TI Inspire, the buttons are in different spots. So we divide by 27. What do we get? 84, 84. Okay, so this is weighted mean, guys and gals. All right, so now we have another type of mean. So, oh wait, let me tell you something, and this I think is interesting. You can regard this here as not as weight. You can regard it as frequency. And you could change this formula to look like this now. Because in reality, what you're saying is 85 happens 9 times. 90 happens 5 times. 81 happens 13 times. That's what you could say. So you could say that this is a mean for a frequency distribution. That's what you could say that is. So that formula looks like that. It looks exactly like the weighted mean one. They're the same thing when you think about it. They're the same thing. So, what if instead of having a regular frequency distribution, you have a group frequency distribution? So let's say you have, let's say this is heights, then you have 60 to 62, you have 63 to 65, 66 to 68, and 69 to 71. And the frequency here is 4, 5, 8, and 1. So how would you execute this formula here? The sum of x times f divided by the sum of f. How would you do that? Yeah, of course. How would you execute that formula? What would be the x for the first class? See, this is a group frequency distribution. It's the one that we learned how to do early on in this chapter, section 2.1. So what would be the first x? What would be the first x? Just think about that. It happens often, Lee. Yeah. You know how many of your classmates have AIDS? You'd be surprised. I know. All right, guys. So what would represent the first class? 60, 61, 62. What number can we represent the first class? So here's what you're supposed to do. When you have a group frequency distribution like this, you have classes. What you do is you find the midpoint, and the midpoint would represent your class. So the middle number represents the class. So 60 plus 62, get that answer, and divided by 2, you get 61. 63 plus 65 divided by 2. If you want, you can go ahead and you already know that you could add the class with and get the rest. But you add the lower class and the upper class, get that number, then divide that number by 2. And so now you have everything. You can go ahead and find out what 61 times 4 is, what 64 times 5 is, what 67 times 8 is, what 70 times 1 is, right? 61 times 4 is 244. 64 times 5 is 320. 67 times 8, that's 536. 70 times 1 is this. So if you add these up, you get 1,170. If you add the frequencies up, you get 18. So basically, this is 1,170 divided by 18. Mean height is 65. You wouldn't say is, you would say approximately. So in reality, you would say approximately mean height of 65 inches. And the reason is because we're not basing off the original numbers. We're basing off a representation of the original numbers by taking the midpoint of each of the classes. Remember, when we created these classes, we lost the individuality of the original data. If we had access to the original data, we just go ahead and just add up all the numbers and divide by the total amount of numbers there were. Be careful. So now, guys, the mean median mode has gotten a lot harder, and we haven't done median here, but it's gotten more difficult. So it's going to require you to practice, and I will be posting the rest of the assignment with all the answers on there. And if you have questions, you can ask me next class. Yes. Where? Height of 65 inches. I mean, it's not the best one, but you know what I meant. Okay, so we discussed the mean for a frequency distribution, the mean for the weighted mean. They're both pretty much the same. They're both pretty much the same. Now, I want to go ahead and talk about the shape of a distribution. Okay. And this one's not slightly different. Here we go again. By the way, I ran 10 miles this weekend. Well, on Saturday, I ran 10 miles all in one shot after doing legs. And my legs do hurt a little bit, but that's the first time I've ever ran 10 miles. I've never, ever, it's occurred to me to run 10 miles. Like never. Like that's not something that's gone through my mind ever. Like something I could do. So tells you how much you guys are leaving on the table. Because I'm 40, so that means when I was younger, I should have been able to do it. But I never, ever, it never crossed my mind to do it. Like 3 miles was like, wow, a lot, you know? Like 3 miles was like, wow, that's a lot. So imagine how much you're leaving on the table that you're young right now. It's such a waste of time. We waste time when we're young. All right, let's take a look at, well, this is number 51. and they're going to talk about distribution of that, the shape of the data. And let me change the board up there because you can't see what I'm doing. Don't you think this is pretty cool, guys? This board here? You don't think it's cool? I think I'm gonna buy one for my house. Probably won't end up using it. My kindergartner falls asleep in class, doesn't listen to us. All she wants is toys. Okay, so 51, they want to start talking about shape of a distribution. And basically, I think I should kind of, before doing the question, I should pretty much just kind of fill you in on different shapes that we're looking at. So, and of course, we haven't done normal distribution, but that's not really good. Let me do it better. So this type of distribution is what we refer to as a right skew, sometimes a positive skew. Okay. I mean, I did it almost, it looks almost like I didn't even skew it enough. It's like, there, that's better. Skewed to the right. But you also can have a skew that's to the left. So, in other words, the easiest way to tell the skew is you look at where the tail is, the long tail, because there's two tails, but the long tail. And so those, it could be right skew or left skew, or sometimes could be symmetric. Thank you. I'll grade in a bit. Okay, Mama? Go, you're gonna go bowling today, right?
Yeah.
Good luck. Now, a few interesting things that I should talk about now is if you look at this here, the symmetric one, the mode is in the middle, the mean is in the middle, and the median is in the middle. So in theory, it's perfectly symmetric. Mean equals the median, which equals the mode. Okay, mean equals the median, which equals the mode. But if you look over here on the right skew, what happens is these numbers here pull the mean over to the right. Sometimes these numbers might be called outliers. Sometimes these numbers are outliers. Sometimes not. They're kind of a little bit bigger, but regardless, they skew the data to the right and they pull the mean, I guess you could say, to the right. The median is not as affected by it, so it lags a little bit behind the mean in this case. And the mode is the one that's most repeated, so it's the peak right here. It's the peak. Similarly, when you have the numbers are really small compared to the rest, the mean is then pulled towards the left tail and the left skew. So here's the mean. The median is a little bit bigger. It's not as pulled by the outliers or by the small numbers in this case. And the mode continues being the big number. No, not the big number, the one that's most frequent. So in the right skew situation, the mean is bigger. Let me write that nicely. The mean is bigger than the median, which is bigger than the mode. And the other case, in the right and the left skew, the mean is less than the median, which is less than the mode. Now, why is this important? Because when we start looking at the shape of the distribution, we're also going to ask the question, what is the best representative of the measure of central tendency? Or which number is the typical number? So the mean, the median, and the mode is our attempt to try and pick a typical number of this data set. Better yet said, the measure of central tendency. So let's say, you know, you guys have a part-time after school, and basically you guys make 20 bucks after school. One person makes 20, another kid makes 25, another kid makes 20, another kid makes 25, another kid makes 30. But then there's one kid who instead his dad hooks him up with $200 for that day. So if I were to do an average of this, and obviously let's just leave it at that. We're going to do the mean. 20 plus 25 plus 20 plus 25 plus 30 plus, let's just make it egregious. 2,000. His dad hooked him up with $2,000. Something ridiculous like that. This adds up to 2,120, and we're going to divide it by 6. So the average salary for the kids that day would have been $353. Would that make sense? Would that be an accurate representation of that class? No, not at all. Now let me go ahead and put these numbers in order quickly. So I'm going to switch. I'm going to switch this here, this 5, and this 20 here. Right. I switch them. So are the numbers in order? What would be the median for that? You add 25 plus 25 and divided by 2. That comes out to 25. So what's a better representative of the average part-time salary for these kids, or whatever they make? Would it be the median or the mean? The median is a much better representative of the central tendency, because that 2,000 there is definitely an outlier. And what it did is it dragged out the mean. It made everybody look like they made more money than they did. So sometimes it's better to use the median versus the mean. In fact, this particular type of data was skewed to the right. Because of that outlier being so big, it pulled the mean towards it. But the median wasn't as affected. In fact, the median is what we refer to as resistant to outliers. So whenever there are outliers, whenever there's skew in my data, whenever my data is not symmetric, we tend to want to use our median. However, our median is not as well fitted for calculations because it's based on a position. Okay? But that's why it's so important. When somebody says average, you say, what average are you talking about? Are you talking about the median, or are you talking about the mean? That's why we make a big deal about it. So aside from that, let's go ahead and just tackle the problem that's given in the book. And let me scroll up the board over there as well. So here's the numbers they give. They give 6, 9, 7, 14, 4, 5, 6, 8, 4, 11, 10, 6, 8, 6, 5, 7, 6, 6, 3, 11. And they want you to make 6 classes out of this, which is quite a lot for such a little bit of numbers, but whatever. So they want 6 classes. And then I guess we're going to graph it and talk about the skews. All right, so yeah, definitely these numbers are out of order, but what's the biggest number there? At 14. So 14. What's the smallest number? 3. And we're going to divide this by 6, right? This is going to be our class width, right? So 14 minus 3 is 11. 11 divided by 6 is 1.83. All right, so round it up to 2, right? Round it up to 2. Let's see how it looks. So here's our class. Smallest number is 3, plus 2 is 5, plus 2 is 7, plus 2 is 9, plus 2 is 11, plus 2 is 13. Agreed? 4, 6, 8, 10, 12. 12 plus 2 is 15. Okay. It would be nice if we had the numbers in order. Let's go ahead and put them in order. 3, 4, 5, 5, 5 6s. Be careful. 2 7s. 2 8s. Look, that 4 was hidden. So now I gotta do everything all over again. So there's a 4 here. Or no, I just, yep. There, I think I fixed it. Okay. How many 8s are there? 1 8, right? How many 9s? 1 2 3 4 5 6. 6 6s. Sorry, guys. Again, I gotta fix it.
I have
Yes.
you next week, but I have to take pictures for yearbook.
Okay.
My name is Mariana Guerrero.
O-T, Terrero.
Mhm.
So you want me to mark you present?
Yes.
But you're gonna be missing class, bro.
I'll catch.
Okay,
Thank you.
no problem. All right, so let's continue. I think we're good. So now we have 1 9. And then we have a 10. Then we have 2 11s. And a 14. Uh-oh, we have a problem. Guys, do you see where I messed up? Why am I missing one? How many 4s were there? 2, right? How many 5s? 2. How many 6s? 6. How many 7s? How many 8s? There it is. That's the problem right there. And then 114. There, that is put in order. So how many numbers do I have from 3 to 4? 5 to 6. Uh, 7 through 8. 9 through 10. To 11 through 12. And so this is our data. So let's quickly do a few things. Okay. Let's first draw the distribution now. A quick sketch of it. Let's use midpoints. Just for old time's sake, midpoints. 3 plus 4 is 7. 7 divided by 2 is 3.5. We got 3.5, 5.5, 7.5, 9.5, 11.5, 13.5. Let's draw our axis. Here's our axis. And this goes 1, 2, 3, 4, 5, 6, 7, 8. And this is 3.5. This is 5.5, 7.5, 9.5, 11.5, 13.5. And now we go ahead and do a frequency of 3. And we have a frequency of 8. Then we have a 4. That's a little bit off, but whatever. 4. Then we have a 2. Then we have another 2. And then we have a 1. All right, these are a little bit spread out, but whatever. So what type of skew is that? Is that a left skew, a right skew? It's a right skew. And definitely you can kind of see it. The long tails here. This is a right skew. Right skew. So we just said that the mean is going to be dragged out over there. So therefore, in this case, we should probably lean on using the median as a better representative of the data than the mean. But let's go ahead and calculate the mean. Let's calculate the mean from the original set of numbers, the median. And let's do the mode as well, just because. And so let's do the mode first, because that's easy. The mode is 6. Yes. You're welcome. The median, well, there's 1, 2, 3, 4, 5, 6, 7. Well, so 5 times 4, 20 numbers, right? So 20 divided by 2, the 10th number plus the 11th number divided by 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's the 10th number. Here's the 11th. Those are the middle 2. Add those 2 and divide by 2. That's 12 divided by 2. The median is 6. And now let's go ahead and calculate the mean. 3 plus 4 plus 4 plus 5 plus 5 plus 6 plus 6 plus 6 plus 6 plus 6 plus 6 plus 7 plus 7 plus 8 plus 8 plus 9 plus 10 plus 11 plus 11 plus 14. Enter that and divided by 20, I get the mean is 7.1. So as you could see, because it's a slight right skew, it was dragged out a little bit. The mean was dragged out a little bit. So one interesting little thing is, what if we would have had just this piece of information here? I would have given you this, right? Only this here. And I asked you to calculate the mean. Then that mean would have been approximate, because the mean we calculated was based off the data. But if I gave you that group frequency distribution, you would have had to take 3.5 times 3 plus 5.5 times 8 plus 4, sorry, 7.5. I keep on messing up. 7.5 times 4 plus 9.5 times 2 plus 11.5 times 2 plus 13.5 times 1. All divided by 3 plus 8 plus 4 plus 2 plus 2 plus 1, which is 20. And I want you to, I'm doing this just because I want you to see a difference between this guy and this guy. One is being based off the original numbers, and one is being based off the group frequency numbers, which you wouldn't have. If you just had the group frequency distribution, you could not recreate your original data. 3.5 times 3 plus 5.5 times 8 plus 7.5 times 4 plus 9.5 times 2 plus 11.5 times 2. I'm doing this on my calculator, so plus 13.5 times 1. And my numerator here comes out to 140. And divide that by 20. So in this case, I get exactly 7. And this will be an approximate. It's close. It's close. Not too bad. But it's still off from the actual number of 7.1. And depending on your data, because in some cases, the class width, in this case, the class width was very narrow. But in some cases, the class width might be very wide. And so your error will be bigger. So there's an error there. There's an error because it's the actual 7.1. But it's still good enough. It's the best we can do given the information we have. Obviously, if you have the original data, you do the calculation with the original data. But if you have a group frequency distribution, then you're limited by that. So again, just to summarize, if the data is skewed, the best representative for the sensor is the median. If the data is symmetric, we can choose between the mean or the median, but it's preferable to use the mean because the mean is calculated from all the numbers. So mathematically, it's more sound. Okay. So I think that's it for today. I think that's quite a bit, don't you think? And again, some of you are tapping out and not paying attention. Make sure not to do that.